So hello everyone, my project is nuclear power generation. So first of all, what are power station? These are power station converts one form of energy to another. Like wind power plant will use wind energy and convert it to electricity energy. Thermal power station will use chemical energy of fossil fuels like coal, petroleum or various other fossil fuels to convert to electrical energy. Hydroelectric will use potential energy that gets stored in water that is stored in dam to run turbine and produce electricity. And solar power plant will use sun's energy to produce electricity. How do they do it? They will produce electricity by spinning turbine looking like this. This turbine will be spun by vapor or water. In case of most power plants, steam is used. The only difference between them is the type of fuel they use to convert water to steam, which will then run this turbine, and this mechanical energy will be converted into electrical energy through Faraday's law of electromagnetism. Let's see principle behind nuclear reactor. Nuclear power plant use process known as nuclear fission, in which a nucleus will get disintegrated. Here, uranium-235 example is given. It gets disintegrated into two neutron, one barium nucleus, one krypton nucleus, and some energy when hit by a neutron. This energy is in form of heat energy. This cycle continues and all the hits add up to form enormous amount of heat energy which will be then used to heat up water to get steam to run turbine and produce electricity. There are different stages in nuclear reactor. First of all, reactor core. It is can also be called heart of nuclear power station. It contains fuel, moderator, and control rods, detail of which will be talked later. Coolant system. It is used to cool down the reactor core and carry the heat energy produced by the core to the heat transfer system. Heat transfer system. In this system, heat from the coolant is given to water, which is then converted to steam, which is then used to run turbines. Coolant can be water, heavy water, or any gases, but in heat transfer system, only water is used to form steam. Type of reactors. There are many type of nuclear reactors, but widely two type of reactors are used: pressurized water reactor and boiling water reactor. In pressurized water reactor, there are two different systems as coolant and heat transfer system. Here, coolant will get heated up, then it will get pressurized and flow through another container, which will form steam through water, and which steam will use to run turbine. But in boiling water reactor, the coolant will only get steamed and then used to run turbine. So only one coolant and only one water source is used. Fuel types. Generally, nuclear reactor uranium-235 or plutonium-239 is used. These are the fissile materials which are available easily. Uranium-233 is also used, but it is used in breed reactor not o- in which the fuel is made in the reactor itself and used in the reactor itself. First of all, uranium is extracted, then uranium oxide is made, then pellets are made and fit in a few rods which are pencil-like tubes made of synchronium alloy, which are then assembled together and fitted in the reactor to start the reaction. Control rods and moderators. Control rods control the whole nuclear reaction. As we can see, they are this type of formation. They absorb the excess neutrons inside the reactor. K is known as the neu- neutron reformation constant. It is given as the ratio of neutron produced in a fissile reaction upon neutron produced in the previous fissile reaction. If K is greater than 1, then it is known as supercritical situation in which the neutrons are in excess, and if not controlled then it can lead to hazard and atomic blast. If K is less than 1, then it is known as subcritical situation in which neutrons are lacking, and if not provided then the reaction may stop and the power generation may stop. If K equal to 1, then the reaction is going on well and the power will be sustained. These control rods are made from material like boron 10 and cadmium, as this material exert neutron absorption ability. If K is greater than 1, then these rods automatically go in to absorb neutrons and maintain K equal to 1. If K is less than 1, then they will automatically come out so that more neutrons can be produced. Moderator. Moderator act like a speed breaker for fast moving neutrons. When neutrons are produced in a reaction, they have very high speed. And if these neutrons are used for another reaction, then the reaction may not be carried out because they need to be at a certain speed for the reaction to carry out. So the nuclei of the moderator will act like a speed breaker and slow down the neutron, just like here we see, and it will again cause the chain reaction. This will continue. Moderators used are water, heavy water, and graphite. Heavy water is most commonly used because the 2O can slow down neutron to, to great efficiency, while water can absorb some neutrons cause K to go less than 1. Coolant and heat transfer system. Coolant system. Coolant system is used to safely remove heat and regulate temperature. If temperature is not maintained, then they can go so high that the reactor can melt itself. So coolant are used to remove heat and carry this heat to heat transfer system. Here we can see this is nuclear reactor. Coolant will go enter from here, leave from here, and will go in this chamber where there is water. This coolant will then cool down and the heat will be transferred to water. This is heat transfer system. Here the energy from coolant is transformed to water, which converts water to steam. This steam will run turbines and then it will again get cooled down by again source of other water. This condensed steam will again get into heat transfer system and get reused. Waste and its management. Nuclear wastes are categorized in two types. Firstly, high-level waste and second, low-level waste. Low-level waste includes things that have been used by workers or in surroundings of reactors like clothes, foods, or other protective gears like masks, which have low radioactivity and possesses less threat. High-level waste majorly comes from spent fuel and substance that have been used inside the reactor. Waste should be ma- Waste should be managed efficiently because if not, it can cause hazard. Fuel waste are stored in cool for years so that they can get cooled down. Then they are packed in thick walls of container, and there are two methods to dispose them. One is to store them in dry cask storage with containers of thick iron and lead, and another is to bury them in deep down earth for thousands of years because the fuel waste can be radioactive for thousands of years and can pose threats for thousands of years. Advantages and disadvantages. Nuclear reactor produce electricity through nuclear fission, and so the greenhouse gas emission would be almost zero, like carbon dioxide, SO2, etc. Second, it has high energy density fuel. So if we compare 1 kg of uranium to 1 kg of coal, 1 kg of uranium will give very much high energy as compared to 1 kg of coal. And they help us to get independent of fossil fuels for electricity generation. Disadvantages. One of the biggest disadvantage is nuclear power plant produce radioactive waste. which, if not disposed properly, can cause hazards like talked before. And there are various potential threats like if k is greater than 1 and if reactor becomes supercritical, then there can be nuclear blast like that of Chernobyl. Thank you.